It's recording now. All right, so we're going to finish this up. I put part C. Tell you the truth, I don't even remember what part we're on now. I know we've done this once or twice, right? So I put part C. It doesn't really matter. Let's do an example. One example, and then I'm going to teach you one more new thing. All right, so this kind of is what we did yesterday, but it's an example that we just didn't quite get to. So I'm going to take this. Oops, I didn't want to do that. Guys, Nico, next stop is in the office. You understand me?
Oh, yes, sir.
All right, so let's make this negative. Looks like this is tilted a whole bunch, so I don't know. Let's go like 40. See what that looks like. Yeah, that's pretty close to what it, well, yeah. It's pretty close to what it looks like in the book. Not exactly. Actually, yeah, it's okay. And then I can just rotate it a little bit like that. Yeah, that's kind of what it looks like in the book, if you have your book open. We don't know it's a rhombus. Okay. How do you know what it is, though? You got to go by the information that they give you. You can't just look at it and say, well, it looks like a whatever, right? So you have to go by the information that they give you. And here is the given, all right? And that's what they call it. They call it the given. And they say this. They say, what's that little symbol? Parallelogram. That's right. And let's label this J, K, L, and M right there. All right, so they tell you it's a parallelogram. So that should ring a lot of bells in your head, okay? That should tell you a lot of stuff about this. So if it's a parallelogram, well, obviously there's four sides. That's not that big of a deal. But what's true about the sides, though? The opposite sides are what on a parallelogram? They're parallel because of the definition. But we just learned something, I believe it was yesterday, wasn't it? That what else is true about the opposite sides of a parallelogram? We learned something about the lengths of the opposite sides of a parallelogram. They're equal to each other, right? Okay, so this side and this side are equal. This side right here and this side right here are equal to each other. Everybody got that? We also knew something else about a parallelogram, about the angles. What do we know about the angles? The opposite angles are equal to each other. That's right. Okay, so angles J and L would be equal to each other, and angle K and M would be equal to each other. Okay, that was all yesterday. I think we learned all that stuff yesterday. We also learned about diagonals, but this example doesn't have any diagonals, so we won't worry about that. All right, so they call this side right there X. They call this side 2y plus 1. They call this side 2x. And this side is 5y minus 2. All right? And what else? They call this 7a degrees. It's kind of weird they put an a in there. But it's 7 times some unknown number. Okay, we just don't know what that number is. And this one right here is 13a degrees. And that's everything they tell us. So they ask you, find every angle and every side. So how many answers are we going to get for this? Every angle, how many answers for every angle? 4. How many sides? How many answers altogether? 8. So we're going to get 8 answers to this. Okay? Everybody with me? Okay. So what we're going to do is we're going to see if there's a relationship. Let's do the sides first. You can do either one first. Doesn't matter. They're all kind of independent of each other. All right? Now, the math on this, listen to me, the math on this is going to get a little bit tougher, just a little bit, not much, a little bit tougher than what we've done so far, okay? Do you remember in algebra last year learning about substitution and elimination? You never learned substitution and elimination last year? Okay. You're going to learn substitution today, all right? So here we go. What do we know about these two sides? We already talked about it. This side is what to this side? They're equal to each other, right? So guess what we're going to write down? What are we going to write down? X equals what? 2y plus 1. Good. Whoops, there goes my... Seems like every class I push that button and it makes it go crazy. 2y plus 1. By the way, let's everybody say hi to Trent on 3. Ready? We're going to say hi, Trent. Ready? 1, 2, 3. Hi, Trent. Okay, very good. All right, so let's do... Now, take a look at this right now. Right now, would I be able to solve for x or solve for y? I mean, actually get an actual number. Could I solve for x and y? Could I like subtract something from one side? Could I do something to it to solve for x and y? No, why not? Right, because x and y aren't like terms. I can't subtract them from each other. I can't add them. If I have two variables, listen very carefully. I want everybody's attention. If I have two variables, because this is probably new, all right? From the sounds of it, you didn't do this stuff in Algebra 1, okay? So listen to me right now. I'm going to teach you some algebra that you should have learned last year, okay? If you have two variables and you want to solve for both of them, do we have two variables on this one? Yeah, what are the variables? X and y. If I have two variables, I have to have two equations to be able to solve for both of those variables. Did you hear what I just said? If I have if I have two variables, I need to have what? Two equations. Right now, I only have one equation. Do you think I could get a second equation out of this situation? I set these two equal to each other. Is there anything else that's equal to each other as far as the sides are concerned? Yeah, these two right here, exactly. This side right here and this side right here are also equal to each other, agreed? So I can write that down. So you could write it either way. The x is first here, so let's write the x first here. So I could write 2x equals what? This side here. What's this side? 5y minus 2. So setting it up wasn't really that hard. That's the geometry, okay? The geometry was actually pretty simple on this. The geometry was just the opposite sides are equal to each other, so we set them equal to each other. Does that make sense? It's the algebra that's a little bit tough. So let's take a look. Let's get rid of that box right there. I don't really need that. We have two equations now, and we have two variables. So we should be able to solve for x and y now, okay? If I have two variables, I need two equations. Obviously, they both have to have x and y in it, okay? Like this can't have an a and b, all right? That wouldn't help me. But if this has x and y and this has x and y, if I got two variables and I got two equations, I should be able to solve for x and y, all right? Now watch very carefully. Everybody watch. Go ahead, say it. You got an idea? Go ahead. Nah, we're not going to do x and y intercepts. It's a good call, though, because this kind of looks like an equation on a line. But we don't really have, like, x and y, and we don't have ordered pairs and stuff like that. So we're not going to go that way. But I kind of know what x is on the left equation, don't I? I kind of, a little bit. I don't know it's like 3. I don't know it's 5. I don't know it's -7. I don't know exactly what the number is, but I kind of know what it is. Okay, we say that we have x in terms of y, which means y is part of our answer. So I hope you girls are watching. There's something going on. I don't know what it is, but it's not as important as what I'm doing right here. So let's look. Oh, my Lord. Okay. So what I'm going to do, if x is equal to 2y plus 1 here, the x over here would be the same exact x as this x right here. Everybody hear me on that? Okay, this x, the value for x here, is the same value for x as this is. So what I can do, since I kind of know what x is here, it's 2y plus 1, what do you think I'm going to do with this x right here? Yeah, it's not really combine, but I'm going to like replace it. Okay, everybody see that? See what I'm doing? So if x is 2y plus 1, why not come over here and instead of putting x, what can I put in place of it? A 2y plus 1. Why can I put a 2y plus 1 in for this x? Because x is equal to 2y plus 1. You see that? I did a thing called substitution. We're not going to do the elimination thing. That's for another time, okay? But that's substitution. We substitute x. I should say this. We substitute that 2y plus 1 in for this x. How can I do that? Well, because this is equal to x. Well, I got an x right here, right? So I take this and I plug it in. It's like this. Let's say, I'm just making this up, okay? Don't write this down. What if I had like 3y or 3x plus 1? And then I did a bunch of math. I figured out what x was, and I said x was equal to 2. So we've done substitution. Remember this? You plug it back in. We've done that all year so far, haven't we? We did some math. We got x, and what do we do with that x? We plug it back in. Agreed? So that was substitution, wasn't it? We just took what x is equal to, and we put it in for this x right here. So I would have gone what? 3 times 2 plus 1, and this would be what? That would be 7. Agreed? We're doing the same thing here, except I don't know that x is just 2. I don't know that x is 7. I don't know that x is whatever. But I do know it's 2y plus 1. So what I'm going to do is take that value for x and put it in for the x in the other equation. So let's see what happens then. I've said that enough. What's happening with this x right here? It's being multiplied by 2. So I put a 2, and now I replace that x. What do I replace it with?
That x.
No, come on. Look, I got a circle, got an arrow. Everything's there for you, okay? I replaced this x with a 2y plus 1. Would you agree this is the same as 2x? Why is this 2x? Because over here, x is 2y plus 1, right? So this is 2x. Agreed? All right. But let's write the rest of the equation out. There's my 2x right there. And then let's write the rest of the equation. What would I write? Equals 5y minus 2. Now, take a look at it now. Now look at this equation. How many variables do I have in this equation? How many different variables do I have? I just got one variable, don't I? And that's y. Anybody watching?
Yes.
Okay.
Come on, bro.
Guys, I'm not gonna start unless you're paying attention to me. Jason, that was completely unnecessary. So what I did is I put this x right here. This is x, isn't it? Because it's equal to x. I replaced the other x with this x. Yes or no? I don't see any like nodding of heads. I don't see like confirmation or anything. I don't know. So I can't tell what you're thinking. So it's what I did. X is equal to this, so I put it in for x here. Now look what I can do. Now I can solve for y. I can actually get a real number answer for y. And this is stuff that we've done before. What do I do with this 2? Distribute. Okay, let's see what I get. I get 4y plus 2, and then I don't really do anything to this other side. All I did was just distribute the 2. Now let's get the y's on the same side. So I'm going to put it on the right side. We've discussed that before. I don't want to talk about that. We subtract a 4y from both sides. In the same step, let's get rid of this minus 2 because I got the y on the right side, so let's get rid of this minus 2. I get rid of that by adding a 2. This is all old stuff. We've done plenty of this stuff this year. Let's see what we get now. So that cancels out. This adds up to be a 4. This right there, 5y minus 4y is just y. This adds up to 0 or cancels out. So what's y equal to? Y is equal to 4. So that's half of my answer. Why do I say it's half of my answer? Well, actually, you know what? It's not even half of my answer. It's just finding out what y is because we got to plug it back in, find the lengths of the other sides, okay? But we did find y. That's good. Now what do we have to find? X. Now, do I know what x is equal to? What is it? 2y plus 1. Exactly right. So what I'm going to do is take that x equals 2y plus 1, put that y, which is 4, in for the y. So let's write it down. So x equals 2 times y. We just found y, didn't we? So I'm going to put it in here and then put a plus 1. Let's do the math on this. 8 plus 1 is 9. Now, is that my answer? Do I circle it? I got a little ahead of myself earlier by circling it. No, because what are we trying to actually find? Let's write it up here so I remember. Y is what? 4 and x is 9? Okay. So we're trying to find the lengths of all 4 sides. Well, let's do this in a different color because everything's kind of blending together here. I'll do it in blue. So what's JK? What's side JK equal to?
9.
It's equal to 9 because it's x, isn't it? And so that's got to be 9. Thought I changed it to blue. Why didn't it change to blue? Let's try it again. So x is 9. What's this side over here, LM, going to be? Without doing any math at all, what's this side going to be? It's going to be 9. Would you agree? Because these opposite sides are equal. What if you weren't really sure? Let's put the y in for this. What did we say y was? 4. 2 times 4 is 8, plus 1 is 9. It works, doesn't it? Let's find the other two sides. It's 2x. Well, x was 9, so what's 2 times 9? 18. So that side's 18. What's this side going to be? It's going to be 18. If you wanted to put the y in, you could. Okay, you don't have to because once you find one, you know the other one's going to be exactly the same. Agreed? So let's put the y in just for fun, see if it works. So y is 4. 5 times 4 is 20 minus 2 is 18. It does work, doesn't it? And it should. All right? So now I got all four sides. Everybody with me? Now we got to find the angles. Now, what is the relationship? Let's go different color. Let's go yellow. What's the relationship between this angle? Keep saying I'm going to change colors. I don't know what I'm doing to not do it. There we go. So there's this angle, and there's this angle right here. Are these angles equal to each other? No. But they do have a relationship. What's the relationship between these two angles? They're not congruent. If they're congruent, they'd be equal to each other. What is it? No. Well, they are consecutive. Yeah, they are consecutive angles, but what's the good geometry word that tells us what to do with it? Say it. They're supplementary. Exactly right. They're supplementary. What does supplementary mean? We've talked about that tons of times. They do what? They add up to be 180. Exactly right. Okay? So, now that we know that, let's come over here. I got a little empty area right here. Let's take these two angles. Let's add them up and set them equal to what? 180. Do not, listen to me, do not set them equal to each other. Why do I not set them equal to each other? Because they're not what? They're not equal. That's right. Okay? Look at this. This is a real skinny, acute angle. This is a big old fat, obtuse angle. Okay? There's no way they're equal to each other. Okay? It's a 13A. 13A. And that's a 7A. So we go 7A plus 13A. When we add those two together, we should get 180 degrees. So let's do the math. What's 7A plus 13A? 20A equals 180. Get rid of the 20. Divide. So A is equal to, well, the zeros cancel. It's not 90. It's not 90 because the zeros cancel. 18 divided by 2 is 9. So A is 9. But is that what they're asking for? Are they asking you to solve for A? No, they're not.
Why would he be asking no. Why would he be asking this?
Does anybody listen to anything I say in here? I don't know. Okay, it does not ask for A. It's asked to find all the angles. So look. So how would I find this angle if I know A is equal to 9? Does that mean this angle is 9 degrees? No, it's 7 what? Times 9. That's right. It's 7 times 9. What is 7 times 9? 63 degrees. Now watch this. We got to find all four angles. What's the easiest next angle to find once I got this one? Not adjacent. Opposite. Right, the one opposite. So if this is 63 degrees, what's angle L? It's also 63 degrees, okay? Now, how do I find this angle right here? I could go 13 times 9. I could do that. Or I could take 63, what? From 180. That's right. I could go 180 minus 63. And what's that going to be? 117. So this angle right here is 117 degrees. Angle K is super easy now. How could I find that? It's 117 because it's exactly the same as angle M. So there's my four answers. There's 1, 2, 3, 4. Those are my four angles, okay? And then where's my sides? In blue, right? Let's change this to blue. I'll get these just in a second. Let me circle these. So there's 1, 2, 3, 4 sides. There's my 8 answers, okay? Now, you wouldn't do this on a test or a quiz, just circle them like this. You would write, what would you write? You would write like angle J equals 63 degrees. You would say angle M is equal to 117 degrees, and so forth, okay? Then the sides, what would you say? You would say that JK equals 9. You would say that JM equals 18, again, and so forth. Everybody got that? That's how you would write your answer on a homework or a quiz or a test or something like that. All right? There was a question over here? Yeah.
I wanted to ask, is that just substitution or is that substitution?
We didn't do any elimination today. It was just substitution. I'm not even going to talk about elimination. That's an algebra topic. There is a problem later on that you might have to do elimination for, but I'm not going to. But you could do it by substitution as well, all right? In Algebra 2, you'll definitely do substitution and elimination. So when you get to it, you can say, oh yeah, Mr. Hammer, Say we were going to do this stuff. All right. Let's do one more thing. Not even going to do an example. Just going to show you a theorem. And, whoops. There we go. I'm going to copy and paste that. I'm going to paste it again. And so if I could grab it. Why can't I grab it? All right, Nico, I want you to step outside, please. I want you to step outside. You just chuck something across the room. It doesn't matter. I told you I was going to give you one more warning, and that was it. I gave you your warning earlier. Okay, so I've got, these aren't just any old 3 lines. I copied and pasted them, so what must be true about those 3 lines right there? They're not equal. They're what? Parallel to each other, okay? So all 3 of these lines right here are parallel to each other. What do I call the lines that cross parallel lines like this? Starts with a T. Transversal. Transversal. It's not transphobia. It's a transversal. So it's J. This is K. This is L. This is P, Q, and R. You writing this stuff down?
Yes, sir.
I had a big talk before we even started this lesson about what you should be doing right now. Here's what the theorem says. I'm not going to write it down, but I'll read it to you. It's in the book. That's fine. What's that? There's no MNO. Those are the letters they gave you, so that's what I'm writing it down. You guys are going to listen to me or not? Here it says, listen to. It says if 3 or more parallel lines. Do we have 3 or more parallel lines?
Yes.
Yeah, we got 3 of them, right? It says if it divides a transversal into congruent segments, okay, which means this. Let's change colors. Let's do a little green on this one. Watch this. If these 3 parallel lines cut these transversals, or the transversals cut the 3 parallel lines into congruent segments, which means this, that JK is equal to KL. Everybody see that? So if this transversal cuts 3 parallel lines, and if this JK and KL are equal to each other, guess what is probably true about the little segments over here on this side? They're the same. Now, they're not necessarily the same as these, but they are equal to each other. So here's what we can say. If these are parallel lines, and if JK is equal to KL, then what must be true on the other side? Then those other 2 that are broken up by this transversal must be equal to each other as well. So what could we write? Then PQ must equal what? QR. Okay? That's really important. So if I told you that this was 3 and this was 3 and this was 5, and I asked you to solve for X, okay, finding QR, it would be 5. That's it. It's really simple. It's really simple, okay? As long as these lines are parallel. If these 3 lines right here were not parallel to each other, this would not work, okay? But if these 3 are parallel to each other, these 2 right here are equal, then these 2 right here are equal. Does that mean that this one is equal to this one? No, it doesn't, all right? But it does mean that this one and this one would be the same, okay? That's basically all it's saying. And that's what we can conclude right there. There's no example for that, so I'm not going to do one. All right, but you might have a couple of these on that homework. Now, today, I said I was going to collect 6-1 from you, but we got about 10 minutes, so I'm going to go over some questions you might have on 6-1. Okay? Okay, listen. Price. So I'll collect it at the end of the period, but I'm not going to give you homework tonight because it is a Super Bowl. Go Birds, right? And if you're not an Eagles fan, I will take 5 points off of your homework problem. Okay? I'm just kidding. All right. Go Birds, and we'll see you on Monday.
Take 100 points.